All right, guys, I'm going to go ahead and work number 4 on suggested problems activity 13.1 and 13.2. The actual problem itself is going to be graph k of x equals 3 divided by 2x plus 1, all that subtracted from 4. Right off the bat, I do see that my parent function is going to be 1 over x. And what I need to know about the parent function is some bit of pretty important information. So I'm going to draw the parent function here. So there's my parent function. I have a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Those are important numbers to know because we're going to have to be moving those around as well as the graph itself. On the graph, I have points at 1, 1, -1, -1, 1/2, 2, -1/2, -2. So what I'm going to do with these points is I'm actually going to create a t-chart. Now I'm going to put my asymptotes on there and I'm going to write in error just like you would see on a calculator table. So I have my x values and my y values. And we're going to have -1, -1/2, 0, 1/2, and 1. And of course then we have an error when my y is 0. And then from -1, let me just fill the rest of these in, negative. All right, so I've got those filled in. We're going to use all of these points to help us generate, we're going to transform these points to generate new points to actually help us graph k of x. Now the first thing when I look at k of x, it's not in the form that we are used to. The form that we need is going to be nice and generic, where it's going to be a over b x minus c plus d. Now if you noticed, here on the bottom I have 2x plus 1. Over here I have b times x minus c. So I need to make the 2x plus 1 look to be in this form. Well, the way I do that is I just factor out the 2. When I do that, I'm going to get 3 over 2x plus 1/2, because I have to take the 2 out of the 1, minus 4. Now, the lower part here is what's going to affect the x values on our table. And it's going to actually be opposite. So what I'm going to do is I'm going to add on to my table over here. And I'm going to look at my x's first, and I'm going to think of order of operations. What am I doing to the bottom part of that fraction first? Am I multiplying, or do I multiply or add? So I multiply first because the order of operations PEMDAS. But I'm going to do the opposite. So we're actually going to multiply by 1/2 x, and then we're adding 1/2, so I want to subtract 1/2. Now I have a nice, easy linear formula with points that I can plug in and evaluate, just like what I was doing in Algebra 1. Now for the y, it's everything on the outside, and it's at face value. So if you have a 3 on top, that means you're just going to be multiplying. So I'm going to multiply 3y, and then I'm going to subtract 4 from it. Now I'm going to take each of these x values, all of these x values, I'm going to plug it into this equation. What's important, this error is going to stay error. This error here is going to stay an error when I plug it in there. So I'm going to go ahead and do that. All right, so now I've finished out my table. So my new points, I'm going to have, let's say, my horizontal asymptote, which is actually going to be here, is going to be y equals -4. My vertical asymptote, which is this error here, is going to be x equals -0.5. And then I have a series of points, -1, -7. -0.75, -10, -0.25, and 2, and of course 0 and negative 1. So now what we need to do is actually plot these and make the graph. So here we go. Draw in my XY axis. It's a good XY axis there. Now let's go ahead and put in my asymptotes. I have a horizontal asymptote at y equals negative 4. And x as negative 0.5. Now let's plot the points. I've got negative 1, negative 7. That looks good there. Negative 0.75, negative 10, so that's coming over this way. Negative 0.25 and 2, so that's up here somewhere. And then 0, negative 1, that's down here somewhere. So now I got a pretty good idea on what the graph is actually doing. I just draw it in. Kind of playing connect the dots like you did way before kindergarten. And that's the graph. This will be my graph of k of x. Pretty straightforward to do the transformations. If you learn this process, you're going to be able to do it. Replicate the same idea on number 5, which I'll make another video on.